Hello to another lecture in construction safety, and today we're going to talk about subchapter L, which is scaffolds. As you can see from this picture, scaffolds can be small in size or they can be as big as something like this. This is not exactly an actual picture, but it's a real portrayal of the scaffolding that surrounded the Statue of Liberty while it was being renovated a few years ago. So today we're going to talk about how to properly erect scaffolds, how to dismantle them, how to maintain them, what are some of the safety issues related to the use of scaffolds, and so on. The most frequently cited violations related to scaffolding are fault protection, of course, access to scaffolds, fault protection for aerial lifts, which are parts of scaffold work, planking and decking, or the lack of planking and decking for the scaffold, and training for the employees. So what's a scaffold? A scaffold is an elevated temporary work platform, and there are basically three different types of scaffolds. The first one is called a supported scaffold, something like this. This is considered a supported scaffold. The other one is a suspended scaffold, which is suspended by ropes. So you can imagine something like the window cleaning device for high-rise buildings and things like that. That could be a suspended scaffold. And the third one is man lifts or aerial lifts or cherry pickers or boom trucks. All of these are under man lifts, which is a piece of equipment hydraulically controlled usually, that's used to elevate a person from a lower level to a higher level to work on something, usually used for something like electrical work and things of that sort. So here are some examples of different types of scaffolds. We have the pole scaffold, tube and coupler, tubular welded frame, bricklayer square scaffold, horse scaffolds, carpenter's bracket scaffold. You can read the rest of them, but again, these are all different types of scaffolds that would fall under the three main categories: platform, suspended, or man lifts. Starting with a tube and coupler scaffold, this is one very commonly used in construction. So it's composed of several tubes that are connected together with couplers, something like that. It should have a base on which the tube is going to be erected, or the post, and then the joint for the connection between two posts. So these are the different components of it. And here at the top, this is where the workers are going to stand. You should have planks. It should be properly planked so that they wouldn't have a hazard of tripping and falling and things like that. You can also see diagonal bracing, which adds strength to the scaffold, and cross bracing also does the same thing. To make it move as one unit, you're going to have here the sill that's going to secure a strong footing at the bottom to prevent it from shaking or moving. So this is basically the very simple construction of a tube and coupler scaffold. The major scaffolding hazards, the first of which is going to be falls. Definitely falls are going to be the biggest hazard in scaffolds. Working on an elevated platform or a higher surface, there's always the risk of falls. So unsafe access to mount or to get on that scaffold itself. Planking, if you have bad planking, here what we can see from this graphic description, it shows that the planks were not that strong, so that they could not support the weight of the workers standing on top of them, so they broke, and that could be a major hazard. Lack of fault protection, so if they're going to be working, if you don't have guide rails, for example, or if you don't have personal fault protecting equipment, then that's going to be a problem. Collapse, foundation or structural instability or overloading. If it was overloaded with equipment or material, or too many people standing on the same platform or scaffold, or if it's shaking at the bottom and the ground gives in and it collapses, all of these are reasons for the collapse. Struck by falling tools or debris, especially for people standing underneath or around the platform or the scaffold on the lower level. If something falls from the top, that's going to injure them. And finally, electrocution is going to be also a major hazard, since we can be working close to power lines, active power lines, then we might hit the power line by mistake, and that can cause electrocution, especially in the case of man lifts. As we have learned before, we have something called a competent person. So also in scaffolds, we have a competent person that's going to be dealing with scaffolds. So a competent person means one who is capable of identifying the hazards, existing and predictable, both existing and future, in the surroundings or working conditions which are hazardous or dangerous to employees, and not only being able to identify these hazards, but has the authority to make a prompt action, that is, corrective measures to eliminate those hazards. So that's the definition of a competent person in general. In case of scaffolding, the competent person must be trained in structural integrity of scaffolds to make sure that the different components are strong enough, properly connected. Maintenance requirements, if something needs to be replaced or needs to be fixed. And they have to be also trained in Subpart L, which is this particular subpart with the OSHA standards. The responsibilities of the competent persons are going to include the supervision of the erection, modification, or disassembly of the scaffold, training those who are going to do the same thing, who are going to erect, modify, or disassemble the scaffold, determine what kind of fall protection measures should be taken during erection, modification, and dismantling, inspecting the platform or the scaffold prior to each shift, because again, if there have been some heavy rain, for example, which have made the soil softer, now it can destabilize that scaffold. Or if you have placed too much material, bricks or blocks or whatever, and again that may make it weaker or break. Inspect prior to each shift and determine if mixed components can be used, parts from different manufacturers. Sometimes you can use the scaffold that's completely manufactured by the same manufacturer, or you can use some generic components, connect them together, manufactured by different manufacturers. So we want to make sure that they can work together without causing a threat or a hazard to the people working on that scaffold. So the training must include falls, fall protection, falling object hazards, especially for those who are going to be working on the lower level, power lines and electrocution hazards, the proper scaffold use and what are the proper scaffold load capacities, and you're going to retrain as necessary. If you have introduced a new type of scaffolds, for example, you need to retrain your employees. If you have added new employees, you have to train these new employees. Here's an example of a scaffold, and as you can see, it does not seem very sturdy. The components are bent out of shape, and it doesn't seem to be very strong. And there's a heavy load placed on top of it. I believe these are CMUs or blocks. So the competent person must inspect the scaffold before every shift, must take defective parts out of service or repair them immediately. So these are defective parts. They should be taken out of service immediately. The capacity of the scaffold is 4 times the maximum expected load. So you calculate what's the maximum expected load. Dead load, which is equipment and the weight of the own scaffold, and live load, the weight of people and materials that are going to be placed on that scaffold. Multiply that by 4, and that should be the design capacity of that scaffold. So we call that a factor of safety. So if it's loaded with twice as much, nothing's going to happen. 3 times as much, nothing's going to happen. Even 4 times as much, it should not collapse before that happens. We're now going to look at the different components of the scaffold and where are the weak points in each one of these components and how to safeguard against that. So for the foundations, you should have base plates that are going to distribute the load over a wider area to prevent it from sinking into the ground and destabilizing it. Mud sills must be used on soils and asphalt, again to distribute the load and prevent sinking or settlement. And casters. Casters are basically the wheels for mobile scaffolds, and they may be used on concrete only. Concrete, because the concrete is going to have a solid, smooth, level surface, so there's not going to be any bumps that can destabilize a person, for example, standing or working on top of that platform or scaffold. The second part, after the foundations or the legs, the footings at the bottom, are the structural members. They must be plumb and braced, verticality, horizontality, and then braced with cross braces to provide strength for that scaffold. The platform must be fully planked, so the platform is the area on which people are going to be standing and working. It must be fully planked. This one, for example, is not fully planked, so this is not proper. It should be fully planked on the working levels. If we look at this picture here, for example, how many working levels do we have? We have one here, maybe one here, one here, and one here, and none of them is fully planked. Fully planked, which means across the whole width of this member, we should have these planks. So this is not yet properly assembled. 1 inch maximum gap between the planks. If you're going to place them next to each other, there's going to be only 1 inch maximum gap, again to prevent the hazard of tripping or falling debris either. And it has to support 4 times the maximum load. That's per the specifications for a proper scaffold. We can see here for this one we have the outriggers that increase the base width of the scaffold to improve its strength. We have also the casters, but in this case the casters are going to have some brakes on them to prevent the scaffold from moving while some people are working on top of it. It also has the ladder-like axis, so it's already built in, so people can climb that to get to the upper level on that scaffold. It has the cross bracing, which again is going to offer additional strength. So with the exception of the planking, the proper planking, this looks like a good scaffold. Here are the planks, but they are not properly overlapped. The overlap should always be on top of a joint, and the overlap should be at least 12 inches at supports, unless restrained to prevent movement. So the overlap is always going to be each end over support, so this one should extend to this side here, and there should be at least 12 inches over the support. Remember what we talked about in ladders. If you have a wooden ladder, you shouldn't paint it or apply dark varnish, for example, to it, because that might conceal some of the defects and some of the cracks. Same thing applies here to scaffolds. No paint on wood platforms, because that might cover and hide some of the cracks. Use only scaffold grade wood, and that's going to have a certification or a stamp on it. Fully planked platforms on the working levels. This is a working level here. It seems to be properly planked, and so is this one. Compatible components or pieces, so by the same manufacturer or generic, but they can work together. And erection on stable level ground. So it doesn't show here at the bottom of the scaffold, but there should be some clearing and some good housekeeping to make sure that the footings or the foundations of the scaffold are on solid ground and at the same level to prevent differential settlement and shaking. Scaffold boards are not required to be stamped scaffold grade. It's up to the competent person to determine if boards used to meet scaffold grade requirements. So the competent person is gone. These are the ones used for planking, basically. The best practice is use graded and stamped lumber. This one is going to have the stamp that shows what capacity can it withstand before breaking or collapsing. The scaffold boards must be in good condition, and if not, they should be removed from service. Plywood is not acceptable. In lieu of scaffold boards, they have to be solid wood and not plywood. Now here we have how would you classify this? Would this be a platform scaffold? It's definitely not a suspended scaffold. Here we have several violations, by the way. No fall protection whatsoever, very narrow scaffold not properly erected, no hard hat. So again, several violations in this picture on its own. If platforms or walkways cannot be 18 inches wide, and if the worker could fall more than 10 feet or 10 feet or more, then a worker must be protected by guardrails and or personal fall arrest system. So here this is probably around 10 feet or even more than 10 feet, because this is not the bottom of the picture, as you can see from the legs of this guy here. So this is probably more than 10 feet, and that person can fall from them, and that does not exceed 18 inches in width, so definitely this is a violation. There should be either guardrails or personal fall arrest system. Scaffold to work face distance. We don't want someone to lean too much forward and they can lose their balance and fall if there's a big distance between or space between the face of the scaffold and the working surface. So the maximum is going to be 14 inches for most operations, and we have a leeway or a tolerance of an additional 4 inches for plastering and laving operations, because you're going to allow for the thickness of the plaster itself. So anywhere between 14 and 18 inches maximum space between the scaffold, the face of the scaffold, and the work face distance. For the platform overhang, another thing with the overhangs, which are the cantilevers spanning outside of the supports of the scaffold, think about it as a diving board. What would happen if you stand at the edge of the diving board? It would start bouncing. So this is exactly the same thing. So the minimum overhang is 6 inches over center line of support, unless cleated or otherwise secured from movement. If the platform is 10 feet long or less, the maximum overhang is 12 inches. So we have guidelines for the minimum overhang and the maximum overhang as well. If the platform is longer than 10 feet, then the maximum overhang is going to be 18 inches. So under no conditions can the overhang exceed 18 inches. If the length of the platform is less than 10 feet, then it should not exceed 12 inches. And the minimum is going to be 6 inches. So the minimums are 6, maximum is 18. If you want to create a longer platform and you want to overlap the boards, as we agreed before, we must have this overlap happen over the supports and not less than 12 inches of overlap between the different boards. If you're going to use mixed components from different manufacturers, they must be compatible, and the competent person must check it out to make sure that these components can work together. Now we're also talking about some issues related to scaffold stability, height to width ratio. So how high should it be if it has a limited width? If the scaffold is greater than 4:1 height to width ratio, then it must be guyed, tied, or braced. That's one way of making it stronger or sturdier, or install per manufacturer's recommendations, which are going to be along these same guidelines. So the key number here is a ratio of 4:1. If it's greater than 4:1, it has to be secured in a certain way to prevent it from shaking or moving. If greater than 3 feet wide, it must secure every 26 feet vertically after 4 times the base width. So these are numbers to remember, and this is a graph to explain these numbers. If less than 3 feet wide, you must secure every 20 feet vertically after 4 times the base width. So the first brace is going to be at, or the first tie is going to be at 4 times the width, and then after that is going to be every 26 or every 20 feet, depending on the width of the platform itself. If you do not secure You must either use outriggers, which are going to increase the base width, which is going to change the ratio between the height and the width, because you base it on the width of the base of the platform, or widen the base, add another scaffold section to stabilize. So you want to make it wider to give it better balance. So here we can see ties that are going to tie the scaffold to the facade of the building or the work area. A designer is going to be required when the fabricated frame of scaffolds is greater than 125 feet high. Can a scaffold be more than 125 feet high? Yes, in fact there was a picture. Then you go back very quickly to one of the slides here that showed something like that. It was towards the very beginning. Here you're going to have scaffolds for the whole facade of the building that can exceed 125 feet high. So in this case it has to be designed by a professional engineer. It becomes a design project on its own. And that also applies to things like in heavy construction. If you're going to have a bridge, for example, or something like that, then definitely that's going to be done by a designer. It's not going to be something for anyone to do. The design must be done by a registered professional engineer. If you remember, we have seen that when we were talking about excavation. If the excavation is going to exceed 20 feet, then the support is going to be designed by a professional engineer. Here's another area where a professional engineer is going to design some part of our work that we need to perform. The erector training requirements. You must train the employees who erect or dismantle scaffolds or maintain them. Training must be performed by a competent person. Training must include the hazards, procedures for erecting, and the design criteria. What's the maximum load capacity? When should it be inspected? How is it going to be braced? And so on and so forth. You must train employees who work on scaffolds. Training must be done by a qualified person, in this case the competent person, and it must include fall protection, falling object protection, power line hazards, use of scaffold, handling materials on scaffolds, especially if there's going to be some loose material or some fluid that can cause imbalance to the whole scaffold, and the load capacities on the scaffolds. You have to retrain whenever you change the work site, because each site might have its own characteristics. Change in type of scaffold or fall protection measures, if you're going to use PFAS versus handrails or guardrails. Observed inadequacies in worker performance. If you notice that some of the workers are not paying close attention to the safety precautions for working on scaffolds, then you must retrain them. How are we going to access these scaffolds? This one looks like a good scaffold. It's wide enough. It has the ladder-like access tool. It's properly braced. It's fully planked on the working surfaces. Solid wood, not plywood. And it has, here in this case, it has something that looks like a guardrail and mid-rail here. So this looks like a good scaffold. Access must be provided when platforms are 2 feet or more above or below a point of access. So if the point of access, for example, is this roof slab, and you're going to be working on this scaffold, and there's a difference in elevation between the two levels of 2 or more feet, then you must provide some access, which is going to be something like a ladder or something like that. The methods of access can be either ladders, which could be portable, hook-on, attachable, or stair type. It could also be ramps and walkways, or prefabricated access, ladder frame type scaffold, like the one that we can see here on this slide. This is the ladder frame. Or direct access from another scaffold, and may use building stairs and come out windows. These are all valid ways of access to the scaffold. Never use cross bracing. This is the cross bracing. Some people would climb on this cross bracing. It's not designed for that, so it may collapse. So never use the cross bracing to access the scaffold. Here we have a good end frame that has the ladder type, and the bottom rung has a maximum height of 24 inches. So the maximum height for this rung is 2 feet. Another way of access, as we mentioned, is hook-on or detach or attachable ladders must be installed as soon as safe installation permits. For any damaged pieces, you have either to repair them or take them out of service immediately. You don't want to keep them on site so that people might use them. It can cause injuries or damage. One of the major issues here is power lines. And again, scaffolds are used to access higher elevations which might be very close to power lines. So do not erect scaffolds too close to power lines. The good practice is to stay at least 10 feet away. 10 feet away from the power line. Check clearance requirements. You're going to find these in the code book that talk about the different voltage of the different cables and any additional distance that should be kept above and beyond the 10 feet. So do not erect scaffolds near power lines. Stay 3 feet away from insulated lines less than 300 volts. Stay 10 feet away from non-insulated lines or insulated lines greater than 300 volts. And if it's greater than 50 kilovolts, which is 50,000 volts, stay away 10 feet plus 0.4 inch per kilovolt over 50 kilovolts. So for example, if it's 55 kilovolts, then it's going to be 5 times 0.4 inches. That's a total of an additional 2 inches plus the 10 feet. The increment is going to be very small, but again, at least we are keeping the 10 feet safe distance. Never overload scaffolds because there's going to be the risk of collapsing. Platforms must not deflect more than 1/60th of span when loaded, and that's going to show you if it's overloaded or not. If it sags or deflects more than 1/60 of the span, so if the span, for example, is 60 feet, which is very rare, you will never see an unsupported span of 60 feet, just for the sake of illustration. If it's 60 feet, the sag should not exceed 1 foot, and that's going to be a very big sag. So if it's 10 feet, for example, which is a very normal span for a scaffold, it should not exceed 1/6 of a foot, which is basically 2 inches. Ladders may not be used to increase working height except when, so if you're working already on top of a scaffold and you want to reach a higher elevation, you should not work on a ladder except if the ladder is placed against structure which provides stability other than the scaffold. Ladder legs must be on the same plank, again to make sure that it's stable, it's not going to shake. Scaffold is secured against the force of the ladder, so because that's going to create a concentrated load on the planks of the scaffold. Planks are secured to prevent their movements, and the ladder legs are secured to prevent slippage. So if you do not have all of these conditions, you cannot work on a ladder on top of a scaffold. From time to time and for certain kinds of work, we're going to have mobile scaffolds for painting, for example, and similar other work. So here you can see the worker. It has the guardrails and the mid-rail. It might have a toe board as well to prevent falling debris. It has the ladder type access on both sides. It's properly fully planked on both working surfaces. It has some braces here. It has the casters at the bottom, and it has outriggers to increase the width of the base of the scaffold. Now, if you're going to be working on top of a mobile scaffold like this, the surface must be level. The surface on which the scaffold is going to be moving must be level. The maximum height to base is going to be 2:1. Remember, in other platforms or scaffolds, we talked about 4:1. In this case, since this is going to be mobile or movable, then we're going to reduce that by twofold, so it's going to be only 2:1, and outriggers must be used on both sides. In this case, a competent person must be on site to supervise. The casters, as we have seen on the previous slide, must be on a firm surface like concrete. You cannot use them on dirt, which is going to be uneven. You must inspect surfaces first for holes, etc., because again, if that caster hits a hole or falls into a hole, it might destabilize the whole scaffold and cause it to collapse. You must lock casters prior to scaffold use. You must lock the casters prior to scaffold use, and no one should be on that scaffold while it's being moved. Apply the force low, no more than 5 feet above the base when moving a scaffold. If you're going to be pushing it, for example, or something like that, nothing above 5 feet from the base when moving it. Diagonal bracing is going to be required to prevent racking or collapse of the scaffold. If you have employees on the scaffold, employees must not ride on scaffolds unless the rolling surface, if you're going to be moving it or pushing it from one place to another while the employees are on top of it, you can only do that in very limited conditions. If the rolling surface has no more than 3 degrees out of level, so it's almost 100% level and flat. If the rolling surface is free of pits, holes, and obstructions. If it has any holes or debris or pits, then the employees should dismount from that scaffold until it's moved, and then they can mount it again. The maximum height to base, as we agreed before, for a mobile scaffold is going to be 2:1. Outrigger frames, when used, are on both sides of the scaffold. No employee or any part of the scaffold extend beyond the wheels or casters, because that's going to create a cantilever effect, which might cause destabilization of that and overturning of the scaffold. Make employee aware of the move before we move, so that they are alert and they are paying attention that the scaffold is going to be moved. In case of scaffolds, remember, in general, for fall protection, our magic number was 6 feet. In case of scaffolds, since we're going to have either PFAS or we're going to have guardrails, then the number is increased to 10 feet, because usually scaffolds are going to be needed for more than 6 feet. So the fall protection is going to be required at 10 feet on scaffolds, either PFAS, personal fall arrest system, or guardrails, or netting. You might have a safety net. If the employees are going to be wearing the PFAS as their fall protection measure, they must be trained in PFAS on scaffolds, including the anchorage, what is it going to be anchored to, the lifeline, the lanyard, and the body harness. They must be trained on how to wear them, how to maintain them, how to inspect them, and how to discard the defective components if they have been used before and they have been extended. For example, if the lanyard has been extended already, then it has to be discarded. Use PFAS instead of guardrails on some scaffolds, because again, if the worker needs to work, again, here you can see the distance between the worker, the employee, and the facade of the building, that should not exceed, as we agreed before, anywhere between 14 to 18 inches. So you can use PFAS instead of guardrails on some scaffolds. Use PFAS and guardrails on suspension scaffolds if it's going to be a suspension. So far we're talking about platform scaffolds. We have not discussed suspension yet. But if you're going to be working on a suspension scaffold, use both of them, PFAS and guardrails. Erectors and dismantlers use PFAS when feasible, because by that time you have not yet installed the guardrails, so the only mode of protection is going to be the PFAS. You can notice here that the ends of this scaffold are not properly guarded. We don't have any guardrails on the sides of that scaffold, so it's not properly guarded. The personal fall arrest systems on scaffolds must be attached by lanyard either to a lifeline, either vertical or horizontal, and we have seen these in fall protection, or to a scaffold structural member. Do not attach to scaffold member unless the manufacturer has designed a specific fall anchorage point, location, or device for this purpose, because that's going to take a lot of load. Remember the 1800 pounds that we talked about before. So if it's not designed for that purpose, then you cannot attach to it. The clause in the code here says, for all scaffolds not otherwise specified in paragraphs G1I through G16 or I1 through GI6 of this section, each employee shall be protected by the use of fall arrest system or guardrail systems meeting the requirements of G4 of this section. PFAS is not needed in if other fall protection is provided. The guardrail, as we have learned about it before, is going to be 42 inches plus or minus 3. Here it says it can be as low as 4 inches below the 42 inches. Must be installed along all open sides and ends of the platforms before work begins. For the slide that we showed, that we have seen a couple of slides ago, this one basically, it has not been provided on the ends of that platform, therefore it's not properly guarded. The mid rails are going to be screens, mesh, etc. must run between the top edge of the guardrail system and the scaffold platform. For overhand bricklaying, which is a very specific task, guardrail or PFAS required on all sides except the sides where the work is being done. So here we have the guardrails, and he should be wearing PFAS, but on the side, on the opposite side where he's laying the bricks, you cannot have the guardrail because that defeats the purpose. Laying units such that the work is on the opposite side of the wall from the mason, requiring the mason to lean over the wall to complete the work, then in this case you don't need to have the guardrails. Two boards, screens and nets, etc. are going to be required, or use barricades to restrict access below. So either you're going to have the proper two boards and screens and nets to prevent falling debris from hitting someone who's standing or walking underneath the scaffold, or you're going to have a barricade at the lower level preventing anyone from being there while work is being done on top of the scaffold. If the toe boards are not high enough, and we mentioned before that the height, the proper height of the toe board is going to be 4 inches, so a 2x4 is going to be acceptable. Use screening from toe board to top rail, or use canopies or nets to catch falling objects, or barricade area below. That's if the material is stacked higher than the toe board, like bricks or blocks, which might fall above the toe board. Now for another type of scaffolds, the man lifts, train operators requirement. Operators must be trained on the type of equipment being used. Keep the operator's manual nearby to identify again the proper height, to identify the proper loading, etc. Inspect equipment prior to use. Inspect area above and around, especially for inconsistencies in the flatness and the level of the ground, or for the existence of power lines and things like that. Set up on the level and firm soil, and move with platform lowered. So if you're going to move the man lift, which is what it's used for, you have to lower it and not move it while it's still at the high level. The man lift is not a crane. Do not use it as one. So don't use as a material hoist to lift material to someone working at an upper level. It has to be at least 10 feet from the power line. Fall protection is going to be required. Fall arrest equipment must be utilized, and you must observe the weight capacity of that man lift, not to overload it. Permissible types of loads on the man lifts are going to be solid loads, not fluid loads. So it's going to include personnel, tools, and materials only. You can modify the equipment only with the written consent of the manufacturer, because again, these man lifts are manufactured according to certain specs. So if you want to change these specs, you have to contact the manufacturer, who can tell you whether you can do that change or not. Another form is going to be the man basket. The employee must stand firmly in the basket, no sitting, no climbing on the edge of the basket, no jerry rigging for extra height. You cannot add any additional platforms using planks or ladders or anything on the man lift. You cannot do that. And no tying off, because again, tying off might cause an additional hazard on its own. You should not tie off to adjacent structures, etc., while working from the lift, because if the lift moves, that's going to cause that person to lose his or her balance and fall probably to their death. Here's an example. This is a man lift. This is the cage where they're going to be working. It has, as you can see, guardrails on all sides. This is a fact. This is an example of an accident. Employee was on a fully extended man lift, ran over some bricks because the ground was not level. The boom flexed and sprung, vibrating effect. Worker was thrown from the basket, fell 37 feet to concrete floor. You can imagine what happened. It shows here fatal fact. The third type of scaffolds is the suspension scaffolds. As you can see here, this is suspended from the top instead of being built from the bottom up. The rope suspending the scaffold must hold 6 times the load. Remember, for the scaffolds we had, the platform scaffolds, we had a factor of safety of 4. Now for the suspended scaffold, it's going to be even more strict. It's going to be 6 times the load. Train workers to recognize the hazards. Secure the scaffold to prevent swaying, especially if working in a windy condition. Inspect the ropes by a competent person before each and every shift. And anchor PFAS independently of the scaffold, because you want to have another anchorage point separate from the scaffold itself. You need a competent person for rigging. You need to inspect the equipment before each shift because conditions might change. It must be tied to a structurally sound member capable of supporting 4 times the rated load. So the ropes 6 times, the support system 4 times. Lifelines, cables to the ground. Independent lifelines and hoist cables must reach completely to the ground if you want to move that scaffold or balance the scaffold, especially in case of strong winds and things like that. On suspension scaffolds, we're going to use PFAS at all times, with independent lifelines attached to anchorage point capable of supporting 5,000 pounds. The key number here is 5,000 pounds. If you want to use counterweights used on outrigger beams, they must be of a non-flowable material. So you cannot use sand, you cannot use a liquid, you cannot use cement. It can be something like bricks or blocks or any solid weight. They must be permanently marked with weight and securely attached. That's to give stability to that platform. No fuel-powered equipment, because again, the fuel itself is a flowable material, so you cannot use any fuel-powered equipment on a suspension scaffold. Some of the hazards for suspended scaffolds include high winds, poor foundation, and use of screening can cause the scaffold to collapse. Use of screening here is very interesting because the screening is going to offer certain resistance to the wind. So it's going to increase the surface area that's exposed to the wind, increasing the wind load on the scaffold, which might cause it to collapse. So here you have the screening, which creates a special wind load hazard. Don't work on ice or snow-covered platforms because of issue of slipping. Don't work during storms or high wind because it can destabilize it. Use tag lines on swinging load. Protect suspension ropes from heat and acid because that can corrode them and make them lose part of their cross section, reducing their loading capacity. Again, here the main hazards of scaffolds: falls from elevation, bad planking if it's not properly supported with proper overlap, assembly or structural scaffold collapse if it's not properly braced, or it does not have the proper loading capacity, or it's not properly tied. Struck by falling tools or debris, especially for those who are standing around the scaffold, and electrocution if you're going to be working near power lines. So that basically is our discussion about scaffolds. We have identified 3 different types: the platform, the suspended, and the man lifts. And now we have a few questions for review. At what height must fall protection begin on scaffolds? Remember again, under normal condition it was 6 feet. On scaffold, the magic number is 10 feet. What are the elements of a proper scaffold footing on frame scaffolds? Base plate, mud sills, and casters that are going to provide stability at the bottom. That's the most important part. Which type of man lift requires the use of fall protection? Scissor lifts or boom lifts? The answer is each and every one of them, all of them. Any kind of man lift requires fall protection. How far away must scaffolds be from overhead power lines? Again, remember another magic number, which happens to be the same thing, 10 feet. Minimum is going to be 10 feet. That's basically our lecture about scaffolds. I hope you have learned about the proper installation, the proper maintenance, and the proper use of scaffolds, and I'll see you in another lecture.